didn't show. It was so sad. On Tuesdays. Yeah. And I don't even have to because I have actually can't help because I do stuff that I have. When I go
We'll go out of our way to do
it's fine. And there's a lady who's like, literally, if you ever have free time, just come to my house. I guess. But it's like $15 an hour.
You made it home. Good job, Ben.
That clip.
Somebody screamed.
Well done, Benji.
I was like, what? It's a line to
Now whoever's going to watch this back, they're going to be startled as well.
Yeah, I woke up and I'm gonna stop. But tomorrow,
late at night and I just thought my kid was just like screaming.
Oh shoot, no, oh shoot.
You know what? It's fine. I don't need to complete this.
No, I'll go back and watch the color of the
It will calculate.
Please.
You're like, why am I just listening to myself?
I'm not even
You're just like, hold on.
Maybe he'll just. This is what it's supposed to be.
That was a good clap. I'm pretty proud of that.
I know, that was pretty solid.
Good class. Very good.
Put your hands together for.
Oh, really? That's actually
What does he do? Well.
Yeah. I mean, Nick does look like a drug dealer, but he's actually a son. Why did you say that? Yeah. That's the thing. I think that's a problem. I have a room where they're like walls with pictures. Where I have what's called
So on time, did you finish the goal?
Yes.
Is there any stories on those ones?
It's okay though, because
Not necessarily. I'm picturing
Yeah, you do quarter. Jacob. I'm gonna go track down whoever wrote down. Yeah. No, I'm gonna go track down whoever wrote down the address, their email address. I'm like,
good work. Like haircut? This is not the same.
kind of sad.
That's impressive.
You guys can go to
I was going for like rats.
I don't have a choice. It's still there.
That's just the first one. No.
It's the same amount.
It's gonna be done.
4, 5, 6, 7. Thank you.
I will suck it up.
You can beat them in the sugar bowl. I know, man. 3 points. I was there. Yeah.
I was actually doing my homework, but I walked downstairs. That's not like it. But I was also kind of glad. I feel like Alabama was good.
Yeah, seriously, curse Alabama. I hate you.
Like, went to the top team for so long, every good player wants to go. So maybe we can go.
Yeah, it's like half and half.
We should either be scared or happy.
Yeah, either these problems suck or maybe you just
I don't think it's been a couple months since I haven't gotten it for a while.
Oh, yeah.
Okay.
Oh, we don't like that.
Okay, so the schedule is causing some problems. Like we're scheduled a week from Friday to have a day where like seniors are supposed to job shadow or something. And that's where that's the face.
That's gonna happen.
That's that everything's that face. The sophomores take a pre-ACT that day. So that's coming on not this Friday, but the next Friday. Yeah, so anyway. So there's no school on Monday because of Martin Luther King.
Might as well just take Monday and Tuesday then.
So the schedule's kind of causing problems. But this is the so I can't quite give you a date for the test, but I can tell you this. This is the last homework packet. So there's a purple practice test, a white practice test, and then the test. So we are very close to testing now, so don't fall behind. Questions on that? I don't have a specific date yet, but just know that there's this packet, 2 practice tests, and we're done. So. Okay. Look at the green packet, please. Go number 1. So green packet number 1. Okay, listen. Okay. No one talking. Okay, like with all FRQs, there's information and then there's questions. The information doesn't change, so we don't really need to study it again. It's exactly the same as it was last time we talked. We've got a rate at which people enter a park, a rate at which people leave the park. And as we worked this problem previously, we said that it's really important to document a few things. So I would expect that you, if this were the actual AP test, you would have already had this on your paper. So we would have said, okay, the rate, the amount is the number of people in the park. So we tell the grader that N of T is going to equal number of people in the park. It is required to write this statement. If you do not, you will lose a lot of points. You can't use the symbol N if you don't tell the grader what symbol N represents. Make sure you have that written on your paper. And that is definitely an amount. It's a number of people.
Please. Why do they do that? Like, why don't I just choose a number? Or why don't I just choose a right
Symbol. Is that what you mean?
Yeah.
I do not know, other than their goal is, of course, to constantly check if you're thinking along with them. 2 points, I don't know. Because I'm with you, Josh. I find it awkward. Oh, I've got to invent a symbol now, but I've just gotten used to it. So. Anybody else? Okay, cool. Next thing here, hold on. And now we need a rate at which that number changes. So I would write on my paper, n prime is the in rate subtract the out rate. So E of t minus L of t. And this is very standard for many, many AP problems. Like doing what I've done here, that's going to happen over and over again as you practice the AP test. Questions? Please.
With this specific unit, is this what most of the FRQs will always be set up like?
To be fair,
With breaks and
for this unit, yeah, it's better to kind of maybe think of the AP test. On the AP test, there's probably going to be about 2 problems that will have a feel like this on the FRQ section, but there's only 6 FRQs. So 2 of the FRQs will typically have a feel something like this. This unit, you know, not all problems, not all of them, but it's a decent number. Okay, next thing. So that's just the information. And now we're on to the question. The question says, at what time between hour 9 and 23 does the model predict that the number of people is n, in the park is a maximum? Okay, you should always stop when you hit punctuation. So don't worry about the rest of it. And you can read it quick if you want. Rounded to the nearest whole number. What is the number of people in the park at that time? Justify your answers. But I'm focused right here on finding when n is greatest. So back to my work. So the goal is to find when n is greatest. Question? Okay, we studied this previously. Oh yeah, please do.
Are we going to have to write that out on the test?
You do not have to write this right here. 2 points for Tewila. So that's just me trying to make sure you all understand what I'm doing at the board. So the yellow is not required on the test. Everything above the yellow you do need to write. Because you're going to use it, you've got to have it written down.
Including AMT and weight.
Good comment. These 2 would not be required, I just think they're really helpful.
Okay.
Yeah, 2 points for Kruger as well. There you go. Awesome. Okay, we talked about this in the previous unit. When we need to find when something is greatest, the approach we're going to take is we're going to first identify where does n of t have a relative in this case max. So we want to go see where n of t has a relative max. But we get to use our calculator now, so it's a lot easier than it was in the past. So here's, let's see, the definition is n has a relative max when n changes increase to decrease, which is going to be exactly where n prime changes positive to negative. So I grab my calculator. Load it in. Load in the formulas. I put my n prime here in y3. And I take a look at the graph. My window needs to be 9 to 23. It is, so I zoom fit it. Okay, the green graph is n prime. Questions about anything? So I can see from the green graph that right here, let's drag this over. Let's copy, let's go up here. Okay, so I can see from this green graph that right here, that's where n prime is changing positive to negative. So that's the point where n will have a relative max. Questions? Okay, that's the idea. Solving the problem, we have to get enough things written down because it's the written section of the test. I found that there's some shortcuts you can take that make writing down the proper justification easier and quicker. So I'm going to encourage you to follow this quicker pattern. But that's the idea, is that we want to focus on that time. So we need to go find that time. So go back to here, go second, trace, find the 0. We need to go green, right there, go to the left, go to the right, yes. Make sure it says 0, 15.795. We're going to write that down. So what we just figured out was right here. We figured out that let's go to a new page here. We figured out that n prime of t has a value that is equal to 0 when t is equal to 15.795. Yeah, please.
When looking at the graph, I'm confused with why it's not at the tip of like the first curve on blue.
Right.
Like, yeah, why isn't it not? Unless is the blue L of t?
So the blue is actually, too many things to keep track of here. The blue is E of t. So that's the rate at which people are entering the park.
So then why is it not the most people right there? Because after they start, it starts to go down. More people
So
start leaving.
think of it this way. Starting here, the blue is the rate at which people enter, the red is the rate at which people leave. So whenever the rate at which people are entering is higher than the rate at which people leave, the number in the park's going to keep going up.
Oh, because it doesn't, okay.
Yeah, it's not the number, it's the rate. So blue is the rate at which people are entering. So yes, more and more are entering, more and more. Now less and less are entering, but still more are entering than are leaving.
Oh, this
So-
is like when our area, a lesson comes in. I know.
You can throw in area with this. I'm not sure it always helps, but it can.
So, say L of t, it's sorry, I'll take this off. Say L of t is like greater values than E of t. So for n prime of t, would we write L of t minus E of t instead of E of t?
No, all you want to do is always make your overall rate, like we did here. 2 points for Dylan, 2 for Emmett. You want to make your overall rate, the in rate subtract the out rate. The in rate subtract the out rate. and then everything will work automatically. Once this rate here, the red, is higher than the blue, because it's this minus this rate will become negative, which is what you expect, meaning the number in the park will be going down.
Will where our green line has a 0 always be where the in rate and out rate intersect as well?
Most of the time. They will. I have seen problems where, so we're right here, trying to figure out where n prime is equal to 0, but technically we also have to look where n prime is undefined. I have seen cases where it's not necessarily where they're equal, but where something more interesting happens, causing n prime to be undefined. The most common is where they're equal. 2 points for Jacob. Anybody else? Okay. Okay, so got to keep track of two things here. One is I'm trying to help you understand the idea of what's happening. Second thing I'm trying to get you to do is understand what you have to put on the paper to get points. A problem like this on the next test is going to be worth 12 out of 100. And you lose 3 at a time. So if you don't get the right things on the paper, you're losing 3 points quickly. So that's the idea. Here's what I want to write. I do have to write this right here. Let's circle that. And so I had to have this written so I can use the symbol n. I have to have this written so I can use the symbol n prime. Everything else was just me talking. Then on this page, this is an absolute requirement. If you don't write that, you will lose 3 points. So you tell the grader you understand that n prime is going to be 0 at that time. If there are more times, you list out the additional times. And then we talked about in the previous unit that n could be highest, where n has a relative max, but we also talked about the fact that you have to always check the endpoints. And so now what we're going to do is we are going to do what we call a candidates test. So we're going to understand that n of t, write this down please, n of t will be greatest and actually least. This process finds the highest and the lowest at the same time. The candidates test. So n of t will be greatest and least at either time equal 9, that's the beginning endpoint, time equal 15.795, or time equal 23. On every single problem where they're asking you to find where something is greatest or least, that is always guaranteed. That's what I call the Min Max Theorem. Please.
We have to write this down too?
So this statement, 2 for Jacob, put it back in yellow. This statement is not required. However, you've got to make sure your work indicates that you know it. I'll show you what I mean by that. So you don't have to write the yellow, you have to be thinking it. Because the next thing you're going to do is what we call a candidates test, what they call a candidates test. You're going to write down the number of people at time 9 in this problem was 0. And then you're going to calculate the number of people at time 15.795. I'm getting a little tired of writing out all those decimals, so I'm going to store that value in B. I have to store it anyway, otherwise my computations will have a rounding error. So I need to store that. So I go second quit. It's the x value that I'm storing. I want to put that in alpha B. Make sure I store the right thing, so that looks right, so I'm good there. So come back to here. Jacob's question was, do I have to write the yellow? I do not. But I do have to account for the fact that I must find out how many people are in the park at each of these times. If I don't check each of those times, I will lose points. Did that answer your question, Jacob?
Yes.
Okay. So I've got to find the number of people at time B. Well, this is back to what you did on the gold packet. The number of people at time B is going to equal, there are no people initially, and now if I integrate the rate from time 0 to time B, the rate is n prime. That integral will tell me how different the number of people is at time B compared to time 0. Because whenever you integrate a rate, you find out how much the amount changes, how different the amount is at the two different times. So let's do that. Back to my calculator. So I need to do math 9. I integrate from 0 to B. I'm integrating y3 n prime. Wrong button, shoot. There we go. Okay, 5, 8, 6, 7. Seven, 3, 3. Okay, what the integral is telling you is we're integrating n prime. Therefore, the integral says that if you compare how many people, the value of n at time 0 to the value of n at time b, the value at time b will be 5867 higher than the value of n at time 0. That's what an integral always does. Josh?
Going around that, people.
Awesome. If you round it there, perfectly fine. If you choose not to round it there, but round it in your answer, it's good either way. So this is not my answer yet. So whether you round here or not is kind of your option. 2 points for Josh. Jacob?
Why do we start the integration at time equals 0 instead of time equals 9?
Oh, that is an error. How many noticed that error? Nicely done. Okay, take it for that. That's just me making a mistake. Because they said the park opens at 9. It's perfect. Nicely done. So let's fix that. So erase this one. Back to here. Has anyone done it from 9 to B so I don't have to do it again?
3 and 9.
What'd you get, Hannah?
3,951 if you're rounding.
3,000.
951. That's after rounding.
Thank you. 2 points for Hannah. Question? Please, Mark.
I was just gonna ask how do you store the number that we had from the graphing screen to the
Gotcha. No worries. First thing you've got to think about is on the graphing screen, are you storing the X or the Y? You tell me. Good. It's critical that when you're on the graphing screen, you see that it says X equal. So you there? Once you've got that, you second quit, and then type X because that's what you want to store. Then store. With me?
Yeah.
Doing great, Charlie. Then alpha B.
Okay.
And then press enter. And then make sure that the screen shows the number you expect so that you don't end up losing points because you just accidentally somehow press something wrong.
Okay.
That answers your question?
Yeah.
That's a good one. Anybody else? Okay, back to here. We do have to find the number at time 23. The assumption would be the park's empty at time 23, but we have to justify our answer. So using the candidates test, we do need to show that. that calculation? What'd you get? All right. There's one park employee still left in the park when it closes. So, 2 points for Haley.
And for the n of b, when we put that b into our integral, do we need to store the value from the calculator, or can we just type in 15.795?
Everyone listen to this one. Everybody, look at me. Look up. If you use a rounded value to calculate something on the AP test, you run a high risk of getting the final answer off a tiny bit. And if it's off by that third decimal place, you will lose points. So the rule is store everything. Don't ever do a subsequent computation with a rounded value. Use the stored value, always. Does that make sense? It's a really good question. There you go. Okay, cool. All right. So here's a summary of what's happened. We were trying to figure out when the number of people in the park is greatest. The Min Max Theorem says that's going to occur either where the number has a relative max or at the endpoints. So we have to find out where n has a relative max. Now a shortcut is just go find the critical points of n. So that's what I did here. The critical points of n occur where n prime is equal to 0 or undefined. So the shortcut method of solving this problem, getting all the points, is to say, they want me to find where n is greatest. I'm going to go find where n has critical points. That's the shortcut. So I went and found where n has critical points right here. And now I do the candidates test. This right here is the candidates test. So the green element is required. You would have to include the B since we're going to use that later. These elements are required to get full credit. We had to have the symbols written down. So those two green elements. Questions?
I'm just a little confused. So if we're trying to find n of something, how come we're using n prime in the equation? Like, I kind of get it, but it's not.
It's fair. Let me try and do 2 points for Hannah. Let me try and do a oversimplified example to make it click. So I'm making up numbers now. The number in the park at time 9 we know is 0. That's not made up. Let's just pretend that the rate at which the number in the park changes is a really simple value. We'll say it's 20 people per hour. You okay with that? And then let's say that that's the rate for 8 hours. What would you know about the number in the park after 8 hours?
We multiply that by 8.
Yeah, so you take 20 people per hour, you're taking the rate, and you're multiplying that rate by the length of time for which the rate persists, like for how long the rate lasts. And if that were the case, you'd say, oh, I just figured out a way to use a rate and a duration of time to compute 160 people. And that tells you how different the number in the park is from the beginning time to 8 hours later. Like, it doesn't technically tell you how many people are in the park. It tells you how different the level of people in the park is. Does that make sense?
Yeah.
We do the same thing here. We take a rate and we multiply it by a duration of time.
Oh.
The only difference is we have to do it tiny durations after another,
Right, because
the rate's changing.
Okay.
So when the rate's constant, it's a really simple idea. When the rate is not constant, it's not that much more complicated. It's just integrate instead.
Okay.
But it's the same math.
Okay.
Like this math is the same math as this, really. Does that help?
Just more practice. Okay. Yeah.
Just over and over again. Then you add them up.
Okay.
Perfect. 2 points for Hannah. Anybody else? Okay, back to here. So again, the green elements are required. The rest was me just trying to help you understand. If you go this far, you're still going to lose points because you must write a conclusion. And the best way to write the conclusion is to use their words. So I try not to invent my own words just to save mental effort and to also make sure my answer is safely matching what they would expect. They want to know when does the model predict that the number of people in the park is the maximum? So I'm going to write that down. So here's my concluding answer. Let's pull this stuff out of the way. This is the Min Max Theorem we've been talking about. So here's the conclusion. N of t is greatest at time equal. Now, please notice, they do not tell us to round the time. If you round the time, you lose the points. You have to follow their instructions. So 15, 795. And you have to have units.
Could you say B since you already wrote that down?
You can. Since you've already told the grader that B is equal to this number, you can write time equal B.
And that's not a rounded number out of our calculator?
It is rounded, but it's rounded per their specifications, which is 3 decimal places.
Okay.
Good comment. 2 more for Jacob. I said that badly. It's like there's a difference between the 3 decimal rounding versus the completely stored value in your calculator. Because to be fair, Jacob, even the stored value is rounded. It's just rounded to more decimals. But the rules are, as I said to Cougar, when you're doing a calculation, you must use the stored value so you're rounding as little as possible. If they don't specify when you're writing down an answer, you have to round to 3 decimals. And then if they do specify, you've got to make sure you round as they specify.
But you're good to use B?
You can use B, as long as you told them what B is. So N of t is greatest at time equal that many hours. So I've answered that part. It says, what is the number of people in the park at that time? So I just say, when N of that time. And now I have to round to the nearest whole number. So that was 3951. And now I get full credit for the problem, because I've done everything that they require. My justification was the other things I told you had to have written down. So, questions about anything?
What happened to the 5,067?
That was an error on me.
Oh, I see.
No worries.
Oh, duh.
You're good. Yeah, I remember I went from 0. Yeah, no worries. 2 points. Anybody else?
So when we're finding like N of B or N of 3, if there were people in the park before, instead of 0, that would be the number of people, right? That
I'm going to pay Charlie a ticket. Here's why. You are bringing up a critical idea. It's super important. And it goes back to Hannah's question. Like here, let's take Charlie's example. Let's just say you're working, because it doesn't matter about people in a park. The key to this whole idea is you're going to have to deal with an amount of something. So just pretend that at time 9, there happen to be, let's make it not too hard, 500 people already in the park. Okay, this computation is not telling you how many people are in the park. It's telling you how different is the number of people at 2 different times. Like it's telling you, well, hour 9 compared to 8 hours later, which is hour 17, how different is the number in the park between those 2 times? The difference is 160. So that means the number of people in the park at hour 17 has to be 660. Is that what you meant? Yeah. Perfect. Anybody else? Any other questions about anything? The test you take for Unit 4, 80% of your grade, will have 2 problems on it that expect you to go through this process that I just outlined, trying to find where something is either greatest or least. In fact, I think one of the test questions asks you for both the greatest and the least. But if you do the process, you find both. Like we now know that the least number of people, one second, Haley, is at time 9. So, Haley, please.
So when you have like the 3 categories, the amount and the rate of rate, are EFT and LET a rate?
So what happens is the AP test writers, I've never seen them do anything different. They either give a problem like the one we just talked about, where, as Josh said, it's kind of annoying, but they don't give a symbol to represent the amount. And so you create one and you tell them what it is. And then they'll give you a rate which causes the amount to go up and a rate which causes the amount to go down. So I call that the in rate and the out rate. So these are definitely rates, both of them, but I combine them together into a single rate so that now I match Danica's chart more easily. I've got the number of people, that's my amount, and I've got the rate at which that number changes. It's just that that number is a combination of the 2 rates they gave me.
So do intervals only work when you use a rate in them, and you can't use like N of t? You have to use the N because it's a rate?
2 more for Haley. Let's keep talking about that. The units will tell you, Haley, whether what you're doing is making any sense or not. So notice this. Let's get the whole room. Please raise your hand if you can tell me the units for n prime in this problem. Hands up. Come on. Everybody. What are the units of n prime? Everyone. That's better. What are the units of n prime? Jake, hands up.
People per hour.
Okay, please raise your hand if you agree with Jake. 2 for Jake. Pressure's off. So, look, if I integrate n prime, I'm going to take n prime, I'm going to multiply by dt. That means I'm taking people per hour multiplied by hours. I'm going to get people. That's why here, when we integrated n prime, the number is a number of people. Now, it's not the number of people in the park, it's how different the number in the park is comparing the number at time 9 versus time 15. That's what the integral of the rate always finds for you, is how different is the number of people in the park at hour 9 compared to hour 15. We call that the change in the amount. It's the fundamental theorem. I've been writing it like this. This integral from, say, time 9 to time b is the same as the number in the park at time b subtract the number in the park at time 9. That's the most common way we use the fundamental theorem, is we integrate a rate to find out how much the amount is different, how much the amount changes. If we integrate the amount, Haley asked about this, we don't really get something that makes a whole lot of sense to us. because we are taking people and we're multiplying people by hours. So we get units of people hours, which is, I'm not sure what that's useful for. I don't know if that helped.
No, it did. So I was just wondering why we have like n of t and then we have n prime of t. Why couldn't we just put n of t is equal to whatever n prime of t is equal to? Instead of having two separate symbols, we could just have n of t, or yeah, n of t is equal to e of t minus l of t instead of having n prime.
So if I write, two more for Haley, if I write n of t is equal to e of t minus L of t, I'm making a mistake. Does anyone know why? Like, that's not true. It can't be. Like, there's no way for that to be true. Go ahead, Derek.
N is a number of people, and E of t and L of t are rates.
Very good. This side's people per hour. You can't have a rate equaling an amount. 2 points for Derek, one if your hand was raised. A rate does not equal an amount. You can use a rate to learn something about the amount, but they're not equal. So you can't do this. Is that your question? It kind of goes back to what I was trying to show Hannah right here. I can take a rate, and I can multiply that rate by an amount of time, and I can figure out how much the amount changes. That I can do. But I can't just take a rate and say it's the same as an amount. So, please.
If you can integrate like n prime to be n, can you integrate n double prime to be n prime?
Absolutely.
Will we ever have to do that?
Not as often, but yes. But it's not any harder, it's just the same thing.
Okay.
Yeah, the fundamental theorem, as it applies to n double prime, would look like this. Points for Jake. It's no more difficult to apply. It's the exact same idea. Right.
So just checking that I'm getting it. So they don't necessarily give us an equation for like n of t, but you can find it by doing the integral of like 9 to time t n of n prime of t dt.
Yep.
And that's what you get. That's the equation for n of t.
That's exactly what we did here. And that was actually something we did in the gold homework.
Okay.
That is 100% correct. If I have the rate of change of n, I know for certain that here's my formula for finding any value of n. Start with a known value of n. Add to that the integral of n prime. Now remember, inside the integral, I can't have a t, since I have a t there, so I'll use z.
Would that be n prime?
Thank you. So this is my formula for calculating any number of people in the park at any time I choose. Because this integral will always tell me how different is the number in the park at this time compared to this time. Then you add to it how many were in the park at this starting time, and you know how many are now in the park at that ending time.
Okay.
Absolutely. Question? Cool. You gotta back up here for this strange thing. Anything else? Okay. Let's do another one. Number 2 is as good as any. So number 2 we also studied in the gold packet. this idea of there being pollution in a lake. It says, at what time will the number of gallons of pollutant be at its minimum?
And there are no human beings.
Say again.
Nothing.
2 points for humor. Okay. Right. Missed the joke. What is the amount of pollutant at this time? Justify your answers. So because they're asking me when something is lowest, it's not a relative minimum, it's an absolute minimum. I'm going to use what I call my Min Max Theorem right here. And I'm going to do a candidates test. It's a process of eliminating candidates. So, first thing I want to do is make sure I understand what's amount, what's rate. So on my paper, I'd like you to do the same. Amount in this case, and rate in this case. And now every single person in the room, raise your hand and tell me what belongs in each column. Hands up. There we go. We lost Porter. It's been a rough night. There we go. Hang in there. Mark, what belongs in each column?
Amount is not the gallon, right?
So those are the units. That's perfect. There's nothing wrong with that. So what symbol belongs in this column, Mark?
PSP.
Nicely done. And what belongs in this column?
P prime.
Good. And units would be?
Gallons per day.
Okay, so 2 points if your hand was raised and you knew that. 3 points for Mark.
There's
Please.
not like a time frame on this problem. So
Say it one more time.
There's not like a time frame on this problem. So do we just set it to like a big number?
Kinda. I'll demonstrate in a second. Good comment. 2 points. Haley's noticing they don't give a stop. They do give a start, time 0, but they don't say time ever stops, just keeps going. Okay, first step right here, the shortcut is to go find the critical points. So I'm trying to find out where P is greatest. Trying to find where P is greatest, which means I need to find the critical points of P. So on your paper, you're going to write this. P prime of T is equal to 0 when T is equal to, and you need to find that. So everyone use your calculator. Oh, please, question.
Why don't we, like whatever T is, why don't we do P prime of that number equals 0?
You could, I just don't know it yet. But you could write it that way. That would work. I need everyone to find that T on their calculator. Go. Stop me if you need help. If you found it, just wait for a minute. Somebody catches up. I just found that in cases that you put the faster easier to just points. So it's a tiny bit of extra work. It's almost faster just to do it and think about it. That's so either way, that's perfect. The trouble is it's all about getting points for justifying. And so sometimes if I do the shortcut, the justification is pretty easy. If I try to focus too heavily on the relative min or relative max, I tend to have to write a lot more words. I still get all the points, but it's easy to write it right through.
Probably good. Yours might look better. Oh, there we go. That looks real nice.
Jacob, what'd you get?
30.174.
And I would have stored that in B.
Yeah.
Okay, please raise your hand if you successfully found this number. Show me who got this to work. 2 points, 3 for Jacob. Question. You need to come look at their calculator. Everybody look at me. Look. Haley asked a key question. She noted that there is no ending time. So what I would have done in my calculator is I would have just started guessing. Like I always start with 5. So I would have went 0 to 5, and that would not have been enough. So I just keep guessing. Eventually I get to 0 to 50, it's enough. And so I would graph from 0 to 50. And I zoom in. And then we need to find that place. Because that's the 0 of P prime. So P prime is equal to 0 when time is. What you do is this, just like so you found the value of P at times 0. You found the opposite. No, that's the value of P at times 0. This is graph. Anybody else? Anyone else need me to look at their calculator? Okay, look at me. Look. Okay, remember, I'm teaching you how to find both the min and the max simultaneously so that you're prepared for either question on a test. We have a problem that we do not have an ending time, so we have to account for that somehow. So here's what I would do. I would still do the candidate's test, meaning I would account for, let's see, here's what I would write on my paper. I would write P of 0, they tell me that's 50. Then I would go find P of 30.174. And that's going to equal the amount of plutonate times 0, which is the 50, plus I integrate P prime from time 0 to time B, like that. Questions? So you all have the, all right, please do.
So could we write 50 instead of P of 0 on the second row?
Either way.
Okay.
Either way, 2 points.
As long as you write it up top so that you know they equal each other. Sorry, just right above with the P
Yes,
of 0.
thank you. So they know what P of 0 is. Yep.
Yeah, as long as you stay with that.
2 more for Davis. You all have it in your calculator. Type this integral in if you haven't already. So put that in your calculator. If you haven't done that already, type it in now. Make sure your calculator is working properly. You will stop typing. So get it to work. Still tapping, you're good. Bridger, did you get it? What'd you get? For the integral, what'd you get?
Oh, I didn't get that.
Oh, you haven't got that yet. You have it. What'd you get?
35.104.
And what would the units be, Parker?
Gallons per day.
So be a little careful.
Or just gallons, just an amount.
There we go. So P prime is gallons per day, and we're multiplying that by days, so we get just gallons. 3 points for Parker. Please raise your hand if you successfully got your calculator to work. Who got this to work? 2 points. Yeah. Okay, look. Raise your hand, please. Everybody, come on. Raise your hand and tell me, what does this represent? What is just round it off. What does 35 gallons mean? Like, it's crucial. I've said many times. The fundamental theorem is the most tested concept on the AP test. This is the fundamental theorem. So what does 35 gallons represent? Hands up, come on. What does the 35 gallons represent? Let's go Ty Smith.
At a time equals 30.174, that would be 35.104 gallons.
Everybody listen here close. I'm going to give Ty a full ticket for this. But you're making the mistake that everyone makes every year. It's okay. This is not how many gallons we have at any time. And it never typically is. Like, you need to remember that when you integrate the rate, you don't find how many gallons you have. What do you really find out when you integrate the rate? What is the 35 gallons representing? Hayden?
Are we finding the rates going after?
I'm going to give Hayden a ticket as well. Also, kind of a common misperception. No big deal. The 35 is not how many gallons you have. Like, when you integrate the rate, you do not find out how many gallons you have.
What's our displacement from time equals 0 to time equals b?
Right idea, we just don't want to use the word displacement because it doesn't apply to this situation. So just say it again. What is the 35 representing, Evan?
It's how many gallons we changed by from time equals 0 to time equals b.
There we go. It's how different the number of gallons is between those two times. So there's some number at time 0, some number of gallons. There's some number of gallons at time b. 35 is how different those two amounts are. Jacob.
But since we added how many gallons are at time 0?
Oh, so somebody lied to me. I was just asking for the value of the integral. I didn't want the plus 50.
Oh, no.
That confused everybody. That was my bad. Okay, everybody mark down 5 points.
Let's see whoever confused Mr. Smith.
What's the value of the integral alone? That's what I said. I just did. What'd you get, Jake?
I got negative 14.896.
My apologies. I apologize for misleading you. That's my bad. So say it one more time, Jacob.
Negative 14.896.
0.8.
996.
Thank you. No, Mike. Sorry. Thank you, Jacob. Hey. So the integral is how much the pollution level changes. That's a huge idea. Don't get that mixed up. So sorry about that, Ty. You were right on track with that. So this is how much the pollution level changed between time 0 and time b. Then, like Jacob said, when you add the 50, you now know what the level of pollution is at time 30.174. So Jacob Parr, what's that number again right here?
35.104.
Units?
Gallons.
Thank you. Questions? Awesome. Now to keep going back to Haley's comment. If you stop at this moment, you will lose points. You have to account for the right end point. The trouble is the right end point is infinity.
What is that?
You can't write the number of gallons at infinity. They're going to give you points for that. So what you have to do is a little bit of just simple logic. You look here, and let's see. Let's change our window. Let's go 0 to 50. Zoom fit. This is P prime. What we notice is that after time 30, so right here is time 30. After time 30, let's pull this over here. So after time 30, P prime is positive. If P prime is positive, P is increasing. That's what you write on your paper. So you write down for T greater than 30.174, P prime of T is positive, so P of T is increasing. Therefore, P of T is least at time equal 30.174. Make sure I have units, days. When P of 30.174 is equal to 35.104 gallons. They did not ask for any rounding, so I don't round other than to 3 decimals. 35.104. Questions? Please.
If they had had the same problem and asked for the maximum, would it be possible to find it since it just like keeps increasing until infinity?
Go ahead, take it for that. Listen to Jake. No, it's spot on. In this case, because we have identified that P prime is going to be positive forevermore, and therefore P is going to be increasing forevermore, there is no way to identify the highest value of P. It's going to just keep growing forever. And you just write something like that. I've never actually seen them ask that question, but that would be the correct answer. That makes sense. So then, anybody else? Please, Jacob.
On the first line, do we need to clarify that P of T is increasing on the same interval where P prime of T is positive, or like will they be able to make that connection themselves?
Say it one more time.
Do we need to clarify that?
Which line are you looking at?
The first line of your written explanation.
Right here?
Yeah. At the very end where we say that P of T is increasing, do we need to clarify that we're talking about the same interval of T is greater than?
No, well done. I got you. 2 points. If this doesn't answer, ask again.
Okay.
I have learned from, how do I say it? Okay, there's a dilemma that you will always face on any written test. How do I write my answer in a way that the grader will give me credit? And what I've learned is by studying how they write their answers, this is sufficient. Yeah. When I write for time greater than this, they're totally happy that I'm talking about both of them. Is that what you meant?
Yeah.
Well done. Oh, next one. Okay, this one talks about a particle. This is also a copy from the gold packet. So we have a moving particle. This particle is moving along the x-axis. It says at what time is the greatest distance between what is the greatest distance between the particle and the origin? A little shortcut here. When you have a moving particle, and they ask for the greatest distance between the particle and the origin, they're asking for the min and max of the position. So this problem is asking you to find what is the minimum, I'll just abbreviate, and maximum position of the particle. That's what they're asking for. Question? Please do.
Wait, why are we finding the min as well as the max? It's just asking for the greatest distance.
2 more for Haley. Here's the reason, Haley. I have a particle. It is moving along a line. The origin is the center of my line along which the particle moves. So we call that the location of 0. As the particle goes back and forth, I've answered your question already. 2 points. Anybody else? Cool. Back to here. So it is simply, this whole packet is just practicing the Min Max Theorem, of course. So to find the Min Max Theorem, I want to start out by making sure I'm clear on what the amount is and what the rate is. So everyone in the entire room, please raise your hand. Tell me what symbols go in which column. Hands up. What symbols do I place in each column? Here we go, Derek.
The amount would be position, so you could state that x of t would be the symbol for the position at any given time.
And just pause for 1 second. It's really good. Good news here. X of t is an accepted known symbol for my position along a horizontal motion. So you don't have to define it. You can just start using it. So back to Josh's comment earlier, even though they don't put x of t up here, you can just use it. It's universal, so we're good there. So how many knew that x of t went here? Show me hands. 0.2 for Derek. Joe, please.
So does that mean that you could use x of t on
Any problem dealing with horizontal motion. If the motion's vertical, you can use y of t. 2 points.
Are we not using BFT because it's giving us the rate and we don't have the amount necessarily?
We just haven't written that down yet.
Well, like X
Oh, go
of
ahead.
T for the amount.
Oh, gotcha.
Instead of BFT, because I was thinking BFT and then B prime, but that's not what I want.
Oh, let me comment on that, Hannah. 2 points. That goes back to Jake Hansen's question earlier. He's like, hey, are we going to encounter problems when we've got to deal with the rate of the rate? And we'll integrate the rate of the rate to find the rate itself. That would be a possibility, but the wording tells me that it isn't.
So we'll work it backwards.
Because they want the greatest distance from the particle and the origin. So they want the min and the max of the position. So this is what I'm trying to find the min and the max of. I'm going to do it by integrating the velocity. Please.
If we specify our amount by anything other than x of t, will they dock as points?
No, just as long as you tell them what it is. 2 points. Anybody else? Okay, so we know our amount, we know our rate. We've got to use the Min Max Theorem. So the shortcut is, let's start right here by finding the critical points. So we want to identify, let's see, this says F, but we're dealing with position. So the critical points of position are going to be where x prime or velocity is either 0 or undefined. So first thing you should write on your paper is that. So write on your paper, V of t is equal to 0 when time is equal to whatever. Then you grab your calculator and you go to work. So find that. Go.
This graph isn't nice.
Say again?
This graph is scary.
Graph is scary?
Yeah, it looks easy for him because he only went to 3.
Oh.
I'm not feeling too fearful yet, but
Wait, never mind. Never mind. I figured out why I was scared. We're good.
Set your window max to a
Yeah.
maximum, and then you will see.
well, yeah,
Oh.
get the window right. It does help. So
I imagine that would be
Oh.
yeah, it does oscillate forever. So sine waves. So
No, that's much more family.
is that what you meant? You saw all the oscillations?
Yeah, it went on forever.
Okay, can I remind you of this right here, right?
Yeah.
There you go.
Don't clap.
It's like an audio signal. So if someone can whistle like a nice pure tone, you'll see it.
Oh.
They can't laugh.
Let's laugh and listen.
Whistle again. The fact that it's not
in tune.
yeah, it's not really, I can turn on a tone generator and show you, but now you got me excited to turn on the tone generator, but the bell's gonna ring.
We can use a harmonica.
Hey, so first thing you should write on your paper is V is equal to 0 when time is equal to, anybody find it?
2.507.
There's more than one, right?
Yeah.
So I've got 2.507. We just store that. So we put that in B. There's another time. What's the other time?
3.545.
3.545. I'll put that in C. Is there any other time?
4.342.
Cool. 4.432.
342.
Thank you. 342. Let's put that in D. Any others? Okay. Then all I would do is do my candidates test. So I would write the position of the particle at time 0 is known. What's the position at time 0?
Wait, isn't there also t equals 0?
We're counting for,
For 0?
we could put that in this list, because that is true. You are right, Dylan. If you don't put it in the list, we're okay, because we can use it here as well.
Okay.
It would be more accurate to put it here, though I agree with you. So x of 0 is going, what is x of 0?
1.
Is it 1? The position at time 0 is 1, thank you. I'm on. So I put that down. Sorry, I'm rushing because of the bell. Then I go, the position at time B is going to equal 1 plus the integral from time 0 to time B of the velocity. I use my calculator to find that value. You simply repeat the process for time C and time D. You must also include the final time, which is time 5. So you will do 4 different integrals on your calculator. Once you've done all that, you can write your conclusion and get full credit. Please, go.
When you do the integral on C and D, would you do it from B to C or from 0 to C?
You actually can do it either way.
Okay.
For right now, just because we're running out of time, I would recommend to do this, like this, Gabby. But there is a way to do it the way you said. This is the safest. Good job, you guys.
Imagine trying to find every single one.
Jacob, can we just extend that by like 10 more points, and it's like we have to find 50. That's why I was scared. I was like, love an integral and this ain't it, chief. And now we see why there's only 8 questions. Because each one requires a freaking thesis. Bye, Naomi.
Hey, now, I hear like people cause these have to be like. I'll have to start right now. Yeah, seriously. But I haven't. I don't know. You have to go research.
Yeah, not better. Contribute to society. I'm Gen Z, bro. I can't do that. Alright, Chapman.
Whoa,
So this is coming up. The second, the first comment. Thanks for that. It's great. It's like that. Literally cramped for the veins. Like the most painful injury you can ever have. And then just
I went to the negative, and then watch what happens. Pay attention to how large that signal is. Press that. See if it's small. Yes, what happens is you accidentally press that. And that's why I choke on that. So they do super.
Hi, I'm just gonna be gone next time, so
So they're in the copy center. I'm hoping to get them back today. If you step back a little bit later, she happens. Okay. So you can do your best to stay caught up with cameras.
We're in the back.
That's where I kind of feel like
Oh, I was like, how is that possible? But I was like the second one picked, and I just stayed for
you just have to kind of
So I don't know anything.
you want to get
I was like, are you